Hi everyone, welcome back. If you want to support me with what I'm doing, please press like, and if you haven't subscribed before, please press subscribe. It'd be nice to get to a lot more subscribers. Negative indices. This really mucks up a lot of students and it doesn't make sense to their brain. I spend time on it in the class and I go over it and then I revise it a week later and then I revise it 2 weeks later and keep going until the students get to the point that they're comfortable with it. I do notice when I have a lot of students coming to year 11 and year 12 where we use this a lot and they don't know what they're doing. Go back to the basics. When you're doing the division, most of you would probably know that the m's stay the same and we subtract the 5 and the 2. If you want to go back and look at previous videos, just look at my playlist on index laws and you'll see what's there. So 5 and then you go and subtract the 2 and you get m to the power of 3. And that makes sense to a lot of people. If we really wanted to show it, we could write that m to the 5 is 1, 2, 3, 4, 5. Now, when we're writing divide, it's really a fraction line. When we talk about a fraction, we're talking about divide. So that fraction line there is a divide. So then we've got on the bottom, so this is actually, if you look at it this way, that's the numerator, or the top, and that's the denominator, or the bottom. And I could write denom and all sorts of things there. So the first one is the numerator, or the top, and the second one is the denominator or the bottom. So that becomes an m squared, which is an m times m. Now here's where a lot of people struggle. They don't know how to cancel their fractions. Now really, any m on the top or any m on the bottom, if that was say a 5 and that's a 5, I can ask two different ways. How many times does 5 go into 5? And you could go once. Or I could go 5 into 5 and 5 into 5. So let's have a look at this here. M into m, I'm going to bother to write once, and m into m goes once. So you can always cancel numerators and denominators when you've got multiplication. Can't do it for addition and subtraction. There's special rules about that. So I can cancel also that m, which becomes a 1, and I can cancel that m as well, which becomes a 1. And what's left? On the bottom, I've got this 1 that's left there, but on the top, I've got m times m times m. And remember the original rule that people made up, if you multiply something by itself 3 times, you put a little 3 above it. And of course we don't have to put the 1 on the bottom because it's if we had, for example, 2 on 1, that's just 2. If we had 3 on 1, that's 3. So m cubed, on 1 is just m cubed. So we can go through that same process, but first of all, let's just use the rules. And here's what the rule is, and I'm going to write it this way. When these are powers or indices, or a lot of people overseas call them exponents, you're going to subtract those two numbers. So look back to this one here. The 5 subtract the 2 became the 3, but the m stayed the same. The 2 take the 5 is a minus 3, but the m stays the same. So that's an m to the minus 3. So that's the upside down of this one here. So this one was m to the power of 3, and this is m to the power of minus 3. Or m with an index of 3, m with an index of minus 3. Let's have a look at this way. So what I refer to as, and I used to remember at school, I would have to write out in full. And for my brain to function and I start to understand the question, even though I was really good at maths at the time, I still had to write this out in full. So there's your numerator. So again, that's the top and that one's the bottom when we write this as a fraction. So I've got a fraction bar and I'm going to have an m squared on the top. I'm going to have m to the 5 on the bottom. If I write it out in full, I've got m times m, and on the bottom I've got 1, 2, 3, 4, 5. And just the same as here a moment ago, you can cancel that m with that m, and when we cancel it actually becomes a 1. That's what's mucked up a lot of people. They don't understand that m into m goes once, and m into m goes once, just like 3 into 3 goes once, or 10 into 10 goes once, m into m goes once. Let's do another one. You can cancel the front. I'm cancelling the back at the moment. M into m goes once, m into n goes once, and you go, what are we left with? We're actually left with a 1 times by another 1 on top, so that's a 1, so it's not nothing. So lots of students will write 0 there. And then we've got an m multiplied by m multiplied m, so that's anything multiplied by itself 3 times is m to the power of 3. If I wanted to, I could put that 1 there. So if you have a look what happened, this ended up with an m cubed on the 1, whereas this ended up on 1 on m cubed. So a negative power, this negative power here, or index, it means move it to the denominator and become a positive. So a negative power is move it to the denominator and becomes a positive. Let's have a look at this one over here then. Simple numbers. This is just normal 10 and a normal 2. A lot of people get mixed up and go, oh, don't I subtract them because I subtract the other numbers? I do refer to these as baby numbers. For the students who struggle with it, they're little numbers. And the baby numbers do what babies do. Babies can add and subtract. I always talk about baby could go 3 duckies minus 1 ducky is 2 duckies. So babies can add and subtract, but they can't multiply. So let's have a look what happened here. We've got a 10 divided by 2. How many times does 2 go into 10? 2 goes into 10 5 times. And let's just do it by the rule without long working out. The x stays the same. And when I go 3 divided by a power of 3 divided by a power of 6, or an index of 3 divided by an index 6, I've really got this. I don't normally write this, but I'm going to write it today. I have started writing it in recent years. So really it's a 5, and most people just go 3 take 6 as minus 3. And I've got so many students go, I know it's 3 take 6, but they then do 6 take 3. What does that minus mean? The minus means it moves from a numerator to a denominator. So I'm going to cover the 5. The x to the minus 3 means I can write it down here with a positive 3. So it moves it from the numerator, writes it exactly the same, x with a 3, and moves it to the denominator. And people get mixed up with this rule. Two biggest things in maths are forgetting and getting mixed up. So if they remember the rule, they get mixed up and they go 6 take 3 instead of 3 take 6. They sometimes will go here to the 3, but then they'll move the 5 to the bottom as well. I always talk about the minus 3 is only sitting on the x. It only affects the x. So it's only going to take that to the denominator, not the 5, so the 5 stays on top. With my senior classes, when it gets harder, it's amazing what people do when it gets harder. I write there that that's a numerator, and I write there that that little one here is going to become a denominator. So the 5 stays on the top, and the x to the minus 3 goes to the bottom, and you don't write it with minus 3 anymore. Oh, getting too long, but I'm going to mention this for a moment. So if we had x to the minus 2, what happens with that? It's really a 1x to the minus 2. So the 1 is the numerator. So if you want to see there's a rule, 1 is the numerator, minus 2 means move all of this to the denominator, to the bottom. So that's an x squared. So what happened to the negative? The negative disappeared when I moved it from the numerator. So at the moment that's a numerator. Move it to the bottom. What if I had, let's do similar. 10x to the minus 5. Let's do that one. So the 10 is the numerator. That stays there on the top. And the x to the minus 5 goes to the bottom. So that's x to the 5 written there. Now the big one, or big 2 I should say. If I had 2 to the minus 1, all it means is move the 2 to the denominator. So that becomes a half. 2 to the minus 1 says move the 2 to the denominator. And remember, we don't have 0 on top, we have 1 on top. So if I had x to the minus 1, that means move the x to the denominator and leave a 1 on the top, not 0. Oh, probably too much. I hope it helps. If you're enjoying it, if you're finding it helpful, please let your friends know or encourage them to watch it. Thank you.